guys, so today we're going to talk about lesson 4 in your science textbook. This is on pages 322 and 323. So our question, or our title, the subject of our lesson is, how do scientists draw conclusions? And so there is a question here on Envision It. It says, tell what you think this scientist is writing down. And of course you have to look over to page 323 to see this. What do you think he might be writing down? He is scuba diving, and he is underwater, and he has some ability to write underwater the information or data that he is collecting. And so what we will know, our question that we unlock, and our big question is, I will know how scientists keep records in order to share conclusions with other scientists. And we've talked before about how important it is that scientists compare their work and that they continue to try different things and continue to ask questions and compare their findings so that you can get better, accurate information and results. And so in our inquiry here, we would have been able to do this in class, and I'm sad that we didn't get to, but we're going to, maybe you can do this at home. But if you didn't, we're just going to kind of use some numbers here just to try it out, just so that you can see how we would record the number of paper clips that were picked up in 3 trials and how we would record our information. Okay, so let's assume that we have a cup of paper clips and we dip our magnet into the cup, and the first time that we pull it out, we pull out 28 paper clips. So we would count those paper clips and we would write down the number, and that was our trial number 1. So we put all the paper clips back into the cup and we do it again. And on the second try, we pull our paper clips out, count them, and we have 23. So a little bit different, but not too many. It's just 5 different. On our third try, or trial, we dip our magnet in, pull them out, and this time we get 25 paper clips. Now, either each time we would go down here and shade this, or we can get all 3 of our numbers and then we can go back and shade it. So if I'm going to shade 28, that is almost to 30. So I'm going to draw my line here, and then I'm going to shade in everything below this line. And you can do that with a crayon or a colored pencil or your pencil, just like I did. Okay? And then our second time was 23. And so 23 is right, kind of just a little bit above the middle between 20 and 25. So it's going to come somewhere right in there. And we're going to shade this in. All right, and on our third trial, we picked up exactly 25, and that is a line straight across here, so we don't even need to draw our line. We just need to shade in everything from 25 down. Ooh, that's some rough shading there, guys. Sorry. For time's sake, my shading is not very pretty. Crayons would look so much better. Okay, so then we communicate our data. We compare the records of your data with the records of other people in other groups. So if we had been divided in the classroom in several different groups, then each group would compare their results, and we would maybe say their results were similar. So we would say they were similar, which means they were about the same. And this is assuming if we were in the classroom, we would all be using the same kind of magnets, and so they would all have the same force of pull on these paper clips, and so we should come up with about, our answers should be similar. And then we draw a conclusion. Based on the data you recorded, how many paper clips is your magnet able to pick up? So the largest number was 28. So the magnet must be able to pick up 28 paper clips. If you go on to PearsonRealize.com, which is in your Teams app under Science, you can look at that. You can go to that website, and they do you can do a virtual inquiry. You can do a virtual experiment with the same items, and so virtual experiments are sometimes fun to do too. So you can also see it there if you wish to go and watch that video. Okay, let's look at page 323. So our first section talks about how scientists will record procedures. So they are doing a bouncing ball experiment that we talked about or that you read about in the previous lesson. And so the bouncing ball experiment from the previous lesson identifies different variables to test the hypothesis. How can other scientists use the experiment to get their own results? How can you use the results to draw conclusions? So over here you see that these are the steps that they used in completing their experiment. The question was, a table tennis ball, which is a ping pong ball, will bounce highest on which surface? And so the hypothesis is, what do we think is going to happen? Their hypothesis was, if I drop the ball, then it will bounce highest on the rubber mat because the rubber mat is the most flexible. And so they gathered their materials, or they listed their materials: table tennis ball, piece of wood, rubber mat, piece of carpet, and a meter stick. And so they used 3 different things: wood, rubber mat, and carpet. And then they used the meter stick to measure how high the ball bounced. This is their procedure. They place a piece of wood on the floor, hold the meter stick upright on the wood, drop the table tennis ball from a height of 1 meter onto the wood. Be careful not to push or throw the ball down. You just want to drop it. And then record how high the ball bounces. Then you repeat those same steps using the rubber mat and the piece of carpet, and you write down your information, just like we did in this paperclip trials over here. And so then we analyze what might happen if a procedure is not clearly written. And the answer to that, we'll go back to that in a minute, I'm sorry, we skipped this part. The scientist in the photo above is keeping records of underwater observations. Scientists must also carefully record how they performed experiments in procedures. And a procedure is a set of step-by-step instructions for how to perform a test. And when you write a procedure, you have to be sure to be clear. This allows others to repeat the test to get similar results. When repeating an experiment, it is important to do a test exactly the same way each time. And so you see over here, their procedure was to do it exactly the same time. So that means that they didn't come back and they didn't just drop the ball onto the rubber mat, and then when they got to the carpet, they threw it down or changed the way they did anything. They did it exactly the same way with each surface. So our analyze question is, what might happen if a procedure is not clearly written? And the answer to that is that the test might be performed differently or provide different results. Okay, we're going to stop here for now, and then the next video will be on the next 2 pages, which will be 324 and 325.